Hello everyone. Till now we have learned what do you mean by DCC GARCH and how we are going to create the model in RStudio. Plus we have also learned how we are going to forecast it. So today in this lecture I am going to teach you about how to estimate the correlation and covariance in DCC model. Now as we all know that when we study the DCC model, basically, we are interested in either estimating the correlation matrix or the covariance matrix. Since we are studying the dynamic conditional correlation, which means that the covariance and the correlation will be different at different time period. So let's learn how to extract the covariance and correlation matrices. In the previous video, I have discussed that how to calculate the spillover effect of one variable on the another. That means we have taken the variables of Japan index, Brazil index and China index, and I have also shown you how we are going to calculate the spillover effect of Japan index on Brazil. In this lecture I have taken all the three variables. That means I have seen the spillover effect of Japan index on Brazil as well as the China index. So let me first show you how to calculate the spillover effect, and then we are going to see how we are going to extract the correlation matrix and covariance matrix, as well as how we are going to plot the graphs. So first of all, you have to library RuGarch package and RMGarch package. So let me first give the command. So the first of all, I am going to create the model. As we all know that first step is to create the model. Next step is that we are going to replicate it. Since we all know that in previous lecture I have taken two variables, so I have to replicate two times. Now I am taking all the three variables, so I have to replicate this univariate GARCH three times. So let me replicate it. So now you can see that I have given the command replicate 3. I am creating this model 1. I am replicating the same thing 3 times because I am taking all the three variables. And the next step is to fit the model. So now I have fitted the model. Now you can see the model fit is there, and I am taking all the three variables where I am seeing the spillover effect of Japan index on the Brazil and China. So that's why I have kept Japan index first, and then I have given the Brazil index name and then the China index. Now I have already created the model. Now if I am going to write model fit, so these are my results. So these are my output. We have already discussed about these outputs, so I'm not going to discuss the output again. Now let's see how we are going to extract the correlation matrix and the covariance matrix from this model fit. So first of all, the command will be, I'm storing the command for correlation in correlation. So it's correlation is equals to, I'll be using the command rcor. So rcor and then the name of the model. My name of the model is model fit. Now I have stored the command that I need the correlation matrix in the correlation. Now you can see over here the correlation matrix is created. So this is the correlation Excel that is being created over here, and you can see is 1:3, 1:3 and 1:3:1:7. That means there are 1:3:1:7 matrices, and matrices will be 3 by 3. Now next we want to see the dimensions. So our command will be dim and then the correlation, because we have stored the command in the correlation Excel. So that's why I'll be using the word correlation. Now you can see over here it's giving 3, 3 and 1:3:1:7. It means that there are 1:3:1:7 correlation matrices of 3 by 3, and that means one for each day. And you will get the matrices for 1:3:1:7 days. Now if you are going to write correlation and then you are going to press enter, you are going to get the matrices over there. Now suppose we want to see the last day correlation matrix. I just want to see the last day. That means what is the correlation matrix on 1:3:1:7 day. So for that the command will be correlation, because I have stored the command in correlation. So I'll be writing correlation bracket. then I'll be writing 2 commas because I don't want the correlation matrices before the last rate. So I'm skipping 1 3 1 6 matrices. So that's why I'm writing 2 blank commas, and then I'll write dim correlation, and then since I want 3 by 3, so I'll write 3 and then enter. Now you can see the correlation matrix. So Japan has a correlation with Brazil, and the correlation is they are negatively correlated, and the value is 0.019. And Japan and China are positively correlated, value is 0.001. And Brazil and China are negatively correlated, and the value is 0.011. And you can see on the diagonal there is a 1. Now suppose you want to find all the correlation of Japan and Brazil. That means you want to find all the correlation values of Japan and Brazil. Now if you are going to find out all the correlation of Japan and Brazil, you can observe over here that the correlation of Japan and Brazil is in the second row and first column. This is my first column, this is my second row. So the correlation of Japan and Brazil is in second row and first column. So I'm storing the command in correlation of N225 and BVSP is equals to correlation bracket. First of all, I am writing the name of the row. So I want the second row, first column, and I am keeping the last blank. Because why I am keeping the blank? Because we want that all the correlation should be there. That means I want all the 1317 correlation. So that's why I am keeping it blank. Now enter. Now you can see the correlation matrix is created and all the correlation are being stored over here. These are all the values. Now suppose in the similar way, if I want to find out the correlation between Japan and China, so I'm storing the command in CORN225 underscore SSCI is equals to correlation. Now over here you can see the correlation of Japan and SSCI is in first column and third row. So first of all I have to write the row. So I'll write 3, 1 and comma and then blank because I want all the correlation, and then enter. You can see this value is also created. Now suppose I want to find out the correlation between Brazil and China index. I want all the values. So my command will be, I'm storing again in CORSSCI underscore BVSP is equals to correlation bracket. Now if you will see, the correlation between Brazil and SSCI is in the third row and second column. So I'll write 3, 2 and comma and then blank and then enter. Now you can see it's all the command are being stored over here. Now if we want to plot the correlation chart, so then my command will be plot.ts, and first of all I want to create the correlation chart of Japan and Brazil. So I'll be writing COR N225 and Brazil because I have stored the command over here in COR N225 underscore BVSP, and then press enter. Now you can see your correlation graph is ready. Similarly, if you want the correlation graph for Japan and China, so I'll be writing COR N225 and SSCI, and the graph is here. And the last graph is plot.ts. I want the correlation matrix of SSCI and BVSP, and then press enter. So this is the graph. But suppose you want to compare all these three graphs and you want to see all these three graphs in the same window. So when this is a situation, So in that way you have to give the command par mfro is equals to C. Now in this I want that all the graphs should be in one window, so I'll write 3 because 3 graphs are there, and I want in one row, so I'll be writing 3, 1. This will create a frame where all the 3 plots will be there in the one window. Now if I'm going to give the command plot.ts and corn225 BVSP, I'm going to get the command in the same. Now you are seeing that they are saying that figure margin is too large. So let me do it this way. I want to show you the graph, so that's why I am creating the space for it. Now again I am going to give the command plot.ts. Now you can see the first graph. Next I am giving the next command. Now next I want to see the graph for plot.ts corn N225 SSCI. So this is a correlation matrix graph for Japan and China. And the third graph is for plot.ts. I want for SSCI and BVSP, that means China and Brazil, and this is your third graph. So this is all the graphs in the same window. Now you can compare all the 3 graphs. Now if you are going to compare, you will see that these 2 graphs are somewhat similar and this is totally different. Now this is for the correlation. Now let's come how we are going to see the covariance matrix. Now first of all, let's store the command for the covariance. So I am storing the command for the covariance in covariance. Covariance is equals to rcov and then the name of the model. So my name is model fit. Now as we have stored the command for correlation, similarly we have stored the command for covariance also. Now let's see the dimension. So I'll be giving the command dim and then covariance. Now similarly you can see that you have 1, 3, 1, 7 covariance matrices of 3 by 3 in which you will be finding one matrix for each day. Now similarly as we have seen in the correlation, suppose I also want to find out the covariance on the last day. So for that my command will be covariance bracket. I'll be leaving 2 commas because I don't want for the previous days. I only want for 1/3/17th day. So I'll be writing dim covariance and then 3 and then enter. Now you can see this is your covariance matrix of 3 by 3. Now similarly if you want to find out all the covariance of the matrices, that means you want to find all the covariance, or you want to plot the graph of all the covariance of 1/3/17 days. So let's store the command. So I'm storing the command cov n225 underscore bvsp is equals to covariance, and as we have done in correlation, so this will be 2, 1, and then I have to leave the blank because I want all the covariance. Similarly, I'll store the other command also. N225 underscore SSCI is equals to covariance. And this is the third row, first column and then blank. And the last is covariance of SSCI underscore BVSP is equals to covariance, and over here this is the third row, second column and then blank. Now if you want to plot the graph, you can plot, give the command plot.ts and name of the matrix. So covariance N225 BVSP, and this will be your graph. Similarly, you want to give the graph for plot.ts, and next is your covariance SSCI. This is your second graph, and third is plot.ts, and you want for covariance SSCI BVSP, and this is your third graph. So in this way you can extract the graph of correlation as well as the covariance, and if you want to find out all the covariance, then you can simply write the command covariance n2 to 5 for whatever covariance you want to find out between two variables. You can just write the name and then press enter. So now you can see that you will find all the covariance of Japan and Brazil. So that was how we are going to extract the values of the correlation and covariance in DCC model. Thank you.